This is an interesting little one. So we are asked to sum between r equals 0 and n, a to the power of r, nCr, where a is basically any constant. Okay, so let's just expand this and see what the series actually is by putting r equals 0, 1, etc. So basically it equals nc0 a to the 0, add nc1 a to the 1, add nc2 a to the 2, add nc n minus 1 a to the n minus 1, add nc a to the n. Okay, right, now let's have a look at the binomial expansion of p plus q to the n. And that is nc0 p to the 0 q to the n, add nc1 p to the 1 q to the n minus 1, add nc2 p squared q to the n minus 2, add ncn minus 1 p to the n minus 1 q to the 1, add ncn p to the n q to the 0. Okay, now if we look at these two here, they are almost the same. And if we do this very clever trick, I must admit, some tricks in maths, they just make you smile. If we add 1 to the n there, and we add 1 to the n minus 1 there, and of course 1 to the power of anything is 1, so adding 1 to any expression still leaves it as 1, adding 1 to there, n minus 2, adding 1 here to the power of 1, and adding 1 here to the power of 0, of course 1 to the 0 is 1. We haven't changed the expression in the slightest, but when we look at these two, we can see that if we put a as p and 1 as q, then we have already got the sum. The sum is p plus q to the n. So basically we can now just write the solution that the sum between r equals 0 and n of ar nCr is putting a and 1 instead of p and q, a plus 1 to the power of n. Hey presto. Now, in actual fact, this is really powerful. Let's just put a couple of examples up here because let's say, for example, you had in an exam, you had the sum between n and r equals 0 of, I don't know, 3 to the r nCr. Well, the answer to that is 3 plus 1 to the n, which is 4 to the n. What about, for example, if we had the sum between n and r, or r equals 0 and n, of 3 to the n minus r c to the r? Well, 3 to the n minus r, 3 to the r, if we just flip around in this here, our p and q, then it's exactly the same. So the sum of 3 to the n minus r nCr is exactly the same as the sum of 3 to the r nCr, which is 3 plus 1 to the n, which is 4 to the n. And just one more, let's imagine that we had, for example, the sum between r equals 0 and n of, I don't know, 3 to, for example, the power of r plus alpha. And of course, this doesn't work for 3, it works for any number, I'm just using 3, nCr. Well, basically all that is where alpha is a constant. We can just take the alpha out, so that would be 3 to the power of alpha times 3 plus 1 to the n, which is 4 to the n, i.e. 3 to the alpha times 4 to the n. So if, for example, alpha was 2, then we would have 3 to the power of r plus 2 times nCr between r equals 0 would be 3 squared times that, which would be 3 squared times 4 to the n, which would equal 9 times 4 to the n. This is a very, very powerful little thing to remember for exams or maths Olympiads. Okay, hope you found this useful. Please subscribe to the Grester YouTube channel if you did. Thank you very much.